Hello everybody, hope you all are doing really well. Today we'll talk about maximum subarray sum. The problem statement says that find the maximum subarray sum from the given array containing positive as well as negative elements, right? There are two things which you have to consider. What is a subarray, right? And we have to find the maximum subarray sum, right? So there are two terms, subarray as well as subsequence. So a subsequence is a set of elements in an array that may or may not be continuous. So here I've taken a few examples. From this array, which consists of 1, 2, 3, minus 2 and 5, I've taken elements 1, 3 and 5 which are not continuous, right? They're not next to each other in this array. So that forms a subsequence. The second example can be 1, 2, minus 2, and these are again not continuous. It also can be continuous, right? I've written may or may not be, right? So if I take 2 minus 2, 3 and minus 2, which is another example which I mentioned here, this is also a subsequence. Now a subarray is a set of continuous elements in the array. So if I take a subarray of size 1, I have 1, 2, 3, minus 2 and 5. Now if I want a subarray of size 2, I should take the adjacent elements only. So I'll do 1, 2, then I have 2, 3, then I have 3, minus 2, and then I have minus 2 as well as 5, right? And now if I take again a size of 3, then 1, 2, 3, 3 elements, 3 continuous elements I have to take. 2, 3, minus 2, so 2, 3 as well as minus 2 and 3 minus 2 as well as 5, right? So this is length 3 subarray. If I want to take a length of 4 subarray, I'll do 1, 2, 3, minus 2. Next one would be 2, 3, minus 2 and 5. The entire array also can be considered as a subarray, which is 1, 2, 3, minus 2 as well as 5. Unless in the question they mention that do not take the entire array, you can consider the entire array as a subarray also, right? Now what have they asked us? They've asked us to find the maximum sum, subarray sum. What is subarray sum now? We understood what is subarray. Now what is subarray sum, this entire term, right? So let's see. So in this subarray, we have only one element, right? So all the subarray sums will be the element itself. So the subarray sum of 1 will be 1, of 2 will be 2, 3 will be 3 and so on. But now when we have a subarray of length 2, there are two elements. You have to add those two elements up. So 1 and 2 will give me 3. 2 and 3 will give me a sum of 5. 3 and minus 2 will give me a sum of 1. Minus 2 and 5 will give me a sum of 3. Here we have 1, 2, 3 which is 6. Here we have the sum of 3. This is minus 2, right? So we have, again, I think it's a sum of 6, right? Here we have 4 as the sum. Here we have 5 minus 2 which is 3 plus 5, 8. And we have 13 as this entire sum, right? 6 minus 2, 4, sorry, 9, I'm not wrong, right? 6 minus 2, 4 plus 5, 9, right? So let me just check this, 2 minus 2, 3, 8, okay. So these are the sums, subarray sums, which you've got here, right? So the maximum sum, what can you see, is 9, right? 9 is the maximum sum which we can see in all the subarrays. So that is what you have to return. This will be the answer, right? So this is what they're asking us to do in the question. So suppose I take an example where we have all negative numbers, right? Let's see an example of such type also. So I've taken this, right? This is another array. So I have all negative numbers here. So I have minus 1, okay. Then if I add minus 5 to this, I'll get minus 6. Then you know, and then if you add again minus 6 to this, you're taking all these 3, you'll get minus 12. You know for a fact that if you have a negative sum and if you add another negative number to it, the sum decreases, right? So suppose if you have a sum, current sum, if you have as -1, and if I ask you to add -2 to it, right, what will you get? You get -3, and -1 is greater than -3. So you know that if you add negative values to a negative sum, the sum further decreases. But on adding positive values, if you do -1 plus 5, you get 4. You know that the sum will increase, right? So this idea you have to remember, because they have mentioned explicitly that there will be both positive and negative numbers. And if you know, if the array has only positive numbers, right? So if it has 1, 2, 3 and 7, 1, 2, 3, you know for a fact that the larger the array, more positive numbers get added up and the sum will be large, right? So the best approach is to take all the elements in the array, right? So if you take all the elements in the array, you'll get a maximum sum of 12, 13, sorry, right? So you know this. But what is the constraint here? We have both positive and negative elements. So we directly cannot sum up all the elements and return that as the answer, right? So let's look into the implementation. There are two implementations which we can follow. First one will be like a brute force implementation, right? So let's look into that first. So the main thing I've done here is we have one variable max sum which will store the answer, and I've initialized it to the minimum, right? Because we're trying to find the maximum sum, I'll initialize it to the minimum value. I've implemented this code in C++. So I've used int underscore min, okay, where I've used that to initialize the max sum. And then I have another variable current sum, which is trying to record the current sum in the array, okay. So of each subarray I need to store, right, the sum. So that is what will be stored in current sum, okay. So I've used two for loops. Why have I used two for loops? So I've told you that subarray will have some sort of a start as well as an end, right? So if I start at this, so if this is my I, I'll try to find the sum starting from this, right? So j will move from 2 to 5, okay. The next time I run another I loop, I want to start it from the second element and I will try to find the sum of all of this, right? This will give me, by doing so, we'll try to find all the subarrays in the array. We'll try to find the sum of all of it, right? So that is what I've done here. I've started the I loop from 0 to n, less than n, right? And I've initialized the current sum to 0 because each time I change the start element, I'm trying to find a new sum, okay? So that is why I've made the current sum 0 here. And next, j has started at the ith position, right? Because I need to consider the first element also, right? So in the subarrays, I need to consider 1 also. Before me adding 1 and 2, I need to consider 1 also. That is why I have made j is equal to I, okay? So the current sum will store the sum so far it's obtained. So first the sum will be 1, right? And then it checks if the current sum is greater than the maximum sum, right? So once it does find out that the current sum is greater than maximum sum, then the maximum sum will be, the current sum will be stored in the maximum sum, okay? Next, I will go to the next element. So it will be 1 plus 2 will be done here. And then I see 3 is of course greater than the sum, maximum sum 1. So that will be stored here, right? So if you want, I will write down one loop here so you can understand it better, right? So I'll do that, right? Okay, just ignore the top part. Here I will run j from this, okay, from start to end. So first we'll have a current sum, right? Current sum will be initially 1. Right now 1 is greater than int minimum, right? So the max sum I'll keep max sum here. So max sum will be 1, right? Next we will J will move one step ahead. J was initially here, right? Now J will go to this next element here. So it will add 2 to this previous sum. So I get 3. Now 3 is definitely greater than 1. So this will get updated to 3. Next I will again go to this element. So it will become 6. 6 is greater than 3. So 6 will be the max sum, right? And after I do that, I will move one step ahead, minus 2, right? When I do minus 2, the sum will decrease by 2, so it become 4. And definitely 4 is not greater than 6, so 6 will retain the position in max sum. Then I'll go to 5, right? Now 5, when I do, it become 9. 9 is definitely greater than 6, so max sum gets updated to 9, and that is what we saw in the example here, right? 9 was the answer. So that is um, how we're trying to do. Here we got sub-arrays of 1, 1, 2, 1, 2, 3, 1, 2, 3, minus 2, and so on, right? And if we next change the I position to 2, then we get 2, 2, 3, 2, 3, minus 2, 2, 3, minus 2, 5. That way we're going to cover the entire sub-arrays which are present in this array, right? So that is how we are implementing the brute force approach, right? We will go through all the sub-arrays, keep comparing it to the maximum sum, and as soon as we find the current sum is greater, then I will definitely update the maximum sum. This is the first implementation, okay? And this entire thing is having two loops, right? So, and I'm running both the loops n times, right? So the time complexity, the time taken to run the code will be O of n square, and I've not used any additional space, so it'll be O of 1, right? I've used only max sum and current sum variables which do not occupy space. It will be only at that point of time in the stack it will have a value. So the time complexity of O is O of n square, and the space complexity is O of 1. Now another way to solve this problem is to remove one of these for loops. Ensure that instead of taking O of n square time, we'll make it take O of n time to solve this problem. So how do we do it, right? So in this example, when I was trying to explain, I told you the importance of negative and positive numbers. If the arrays had all positive numbers, then definitely you would take all the elements and then get a big sum. But if it has a negative number, then you'll try to cut down negative numbers and ensure that the sum is positive, right? So what I'm trying to tell you here is, so I told you that if we have minus 1, right, minus 1 will be my current sum. I would not take minus 5. Why would I add minus 5? If I have a negative sum and if I'm adding another negative number, I definitely know that it will decrease, right? So why should I take it? I won't take it. Instead, I will make the sum, I'll reset the sum to 0, right? If it's a negative number, I don't want to add it to the negative sum and make it more negative and further less, right? So that is what I've told you. If I have minus 1 and if I add minus 2, it will become minus 3, which is less than minus 1. So I don't want to add a negative number to a negative sum, right? Because it will decrease my sum and I'll definitely know that I won't get a maximum sum by including that element in the array, right? So that, keeping that idea in mind, I will run a for loop, right? I'll run a for loop again because I need to go through the entire array once. So I'll run this for loop. I'll have a maximum sum variable which keeps a track of the maximum sum it's seen so far. Then I have a current sum which stores the current sum which has been calculated while traversing through the array. Right? So that is what I've done. Current sum is keeping a track of the sum it's seen so far. And then if the current sum is greater than the maximum sum, I'll update maximum sum. Now you can see another condition which I've included here. If current sum is 0, then I'm resetting the sum, right? Why have I done this? This I told you that if I'm getting a sum which is negative, right? It's negative. Why would I want to add another negative value, right? So let me take this example here, right? So first I'll traverse through the loop. I is at the starting, right? So the current sum will add this element, right? So I'll have minus 7 here, right? Now maximum sum is int min, right? So minus 7 is definitely greater than int min. So it gets updated to minus 7 here, right? Now I'll traverse to the next element. Okay. Yeah, sorry. Before I traverse to the next element, it checks this condition, right? So I check this condition and definitely minus 7 is negative. So what I'll do, I will reset it to 0. Okay, only current sum is being reset, but maximum sum is not being reset, right? Because minus 7 is greater than int minimum, so we won't alter that. Next, we see that we have minus 6, right? So now current sum is updated to 0 and we'll have minus 6 as the current sum. You can see here that I've tried to prevent adding minus 6 to minus 7 because I know for a fact it'll give me a value of minus 13, which is not going to give me a maximum sum. So that is why I've reset it here. And now I can check if minus 6 is greater than minus 7. Definitely is. So I get minus 6 here, right? So then again, I know the sum is negative, so I'll reset the value of current sum to 0. Then minus 4 it comes here, so the current sum becomes minus 4. Minus 4 is greater, so I'll do that here. And again, I check the sum is negative, right? Current sum is negative here, sorry. So you get 0. I'll reset it to 0. Then again, I do minus 2. Then minus 2 is definitely greater than minus 4. So max sum will be minus 2. But I know the current sum is negative again, right? So I'll reset it to 0. Then I have minus 5 here, right? So minus 5 is not greater than minus 2. So minus 2 will be my answer. So if an array has a log, all of them are negative numbers, then definitely the maximum sum will be the greatest negative number, right? So minus 2, as you can see, is the element which is greater than all the other elements in this array. So that is how this logic will work even in an array where all the values are negative. Okay. So you would have another doubt, how would it work for this case, right? So we will consider this case also when we have positive and negative numbers, right? You have to keep in mind that we are only updating current sum and not maximum sum, right? So it's not that you're changing the value or you're removing the minus value from the sum, okay? So I initially was confused too, and then I did realize that only current sum is being updated. So let me just take this example once to just make it all clear once. So let me maybe take minus 3, 2 and say 1 itself, okay, right? So this is the array. Now again I'll have a current sum, okay, so first will be 1, right? So max sum, just I'll make it as CS and MS, okay. So MS will be 1 now, it will be updated to 1. Now I'll go to the next element, which is 2. So current sum will be 3, right? So now, since it's now negative, I won't reset it, right? So that is why I've added 2 to 1. So I get 3 greater than 1, so I'm updating. Next, what do we have? We have minus 3, right? So when we have minus 3, I would, okay, let me make this minus 2 also, okay? So now if I have minus 3, then the current sum will become 0. And of course, 0 is not greater than 3, so I won't update this, right? So next we'll go here, minus 2, right? So the current sum will be minus 2. And now this condition will come where I see that, okay, the sum has gone negative. Let me reset it, okay? So this gets reset to 0, right? Okay, now it's reset to 0. Now I go to current sum, it becomes 1 here, and then I check that, okay, 1 is not greater than 3, so the final answer will be 3. Okay, so you saw here that we have found all the subarray sums, and we came to a conclusion that 3 indeed is the maximum sum. You can check for yourself here that if suppose we consider all the elements, we have 1, 2, 3, 4 minus 5 minus 1, and 3 will be one of the sums, minus 5 will be one of the sums, right? You would get minus 1, minus, see, this will be minus 1, this entire thing will be minus 4. So by doing this, we have avoided all the negative sums, which we know which won't add to find the maximum sum, right? So using this example, I hope you got more clarity that using this method, we can find the maximum subarray sum. Okay, this is also otherwise known as Cadane's algorithm. Okay, you can search for it on the net. This is a fancy name for a simple idea such as this. It's called Cadane algorithm. So this is used in order to find the maximum subarray sum, right? So I hope that this explanation was pretty clear. I know it was a bit lengthy maybe, but I hope the concept is easily understood and you can write the code on your own since you understood the entire idea. Have a great day and thank you.